Okay, I thought I'd go ahead and record a little video here, going over the first question uh, type from homework 4. It's sort of late in the game here, but I got a bunch of questions about this, so I thought I'd just walk through a little demo here. If you're feeling like you need more time on question 1, I am giving an extension through the weekend, so feel free to submit anytime over the weekend or before homework 4. So I'll leave that open for anyone who's feeling sort of stuck with this. The mini exam 4, will be entirely on competitive equilibrium, general equilibrium. So more like question 2 on the homework, and covered in demo 10. So hopefully that alleviates any nerves. I'm not trying to make this class more difficult than it needs to be. So feel free to take your time. Don't stress about it. Okay, so let's just walk through this. I have a similar type setup to homework 4. And sorry if you hear any noise in the background. I'm in a somewhat more noisy location than my typical office. So apologize off the bat here. Okay, so let's just walk through this. We're going to ask similar questions of a similar type setup here to what you've seen in the homework. So we have 30 firms, each with an identical cost structure. This thing generally, just as sort of way of thinking about this, we have costs on the vertical. We have some fixed cost, and this is increasing a little bit faster than linear. And then, yeah, the demand curve is just downward sloping 1-to-1 with an intercept of 10. And then we have 40 firms in the market. So the first thing to do is determine the short-run supply curve. So let's write this down below. So we'll call this part A. So we're determining the short-run supply curve. So two things to do here. First is to find the marginal cost curve. So well, let's graph this. So price on the vertical, quantity on the horizontal. So we're going to come back to this graph after we've found the marginal cost curve. So MC is equal to the first derivative of the cost curve with respect to Q. So fixed cost drops out, and all we're left with is the derivative of the second element of the cost curve. So the power rule, we take the exponent, multiply that as a constant out front, and then decrement the exponent by 1. So we have 3 over 2 times Q, 3 to the 2 minus 1. And that's just 3 over 2 Q to the 1/2, or the square root of Q. So that looks something like this generally. Call this marginal cost. But we always have to worry about cases where average variable cost intersects marginal cost. So if this were true, so if this is AVC, then our marginal cost would not be the supply curve for every Q. we'd have this shutdown condition, which would give us 0 at some quantity before we reached a quantity of 0. So we want to make sure this doesn't happen. So the way we do this is just to check if this happens, and if it does, then where. So AVC, so the way we do this is find the average variable cost and then compare it to marginal cost. So let's calculate average variable cost. So we look at the cost curve, find all of the variable costs, which is everything but this, everything but the fixed cost. So that's just Q to the 3/2. So it's 3/2 Q'd 3/2, and then we divide it by Q, which is just Q to the -1. So we have 3/2 Q, then we have 3/2 minus 1, so that's just 1/2. Okay. So, I did this wrong. So, we don't, this 3/2 doesn't show up in our average variable cost. We're just dividing that last element by Q. Okay, so this is nice because you can probably already see that MC is always greater than AVC, and we don't have to deal with the shutdown condition. So this is actually very nice for us. Okay, so the supply curve is just price equals MC, which we know what the MC is, so let's just replace it with 3/2 Q 1/2. And this is our supply curve. And we're going to subscript this PS and QS. Okay, so that's nice. That's part A. For part B, sorry if you're hearing lots of people in the background laughing. I'm with my extended family at the moment. A bunch of lovely people. So for part B, we want to find the short run equilibrium. So for this equilibrium, we need to find the intersection of the market supply and demand curves. So just graphically, this looks like we have price on the vertical, quantity on the horizontal. We have our demand curve, which we've already graphed, which intersects at 10 and 10 and has a slope of -1. And we next need the supply curve. So to get the supply curve, we want, so this is the supply curve for the firm, but we want the big QS, which is equal to 40 times the little QS. And we know what QS is. We just have to rearrange this equation here. So we have 2/3 PS, which is equal to QS 1/2. So then we just square both sides, which gives us QS is equal to 4/9 PS squared. Okay, so then we plug this into our relationship here, and let me drop to the line below. If QS is equal to 40 times 4/9 PS squared. And this just comes out to be 160 over 9 ps squared. Okay. So maybe one last thing to do here is to take the square root on both sides, which will give us the inverse demand curve. You could do it if you want. It's easier to graph because we have PS is equal to 160 is 40 times 4. I'm just going to plug this into a calculator really quick. Square root of 160. That doesn't come out to be a nice number. But we can have 4 over 3 times the square root of 10 times the square root of QS. Okay. So we have this nice relationship. It goes through 0, and it looks generally something like this. It's kind of bending downward. And this is our supply curve, and this is our demand curve. Okay. So we want to find prices and quantities prevailing in the market. So to do this, we take our price or our quantity and plug it into the demand curve. So our demand curve is 10 minus Q. And maybe we'll modify this a little bit. This is the market quantity. I'm sorry. This is price. We're saying this is the quantity demanded. In this, because it's a slope of -1, it doesn't matter how we define it, but just for clarity, let's just rewrite this. Okay, and this is the price for the buyer. All right. So let's set this equal to the demand curve. Maybe we'll do this down here. We have price for the seller equal to the price for the buyer. Price for the buyer is equal to 10 minus QD. And the price for the seller is equal to 4/3 times the square root of 10 times QS to the 1/2. So here, we should combine terms. Let's just bring all the Q's to the left-hand side. So we have Q. I'm going to drop the subscripts here because we're saying QD is equal to QS in equilibrium. So we have Q plus square root of 10 4/3 Q 1/2 is equal to 10. Okay, so this looks pretty messy, and isn't going to be that fun. So, because I am an overlord, I'm going to modify our question just to make this simpler for me and for you to follow, hopefully. So what we're going to do is change this to a 2, which is going to be very similar to your homework problem. But hopefully I've already thrown you off my tracks far enough. So this is going to be it's going to be 2 times Q. Our average variable cost is going to look like this. Marginal cost as a graph will look like this. And again, our condition here holds. Rearranging our supply curve is just 2Q. Price is equal to 2Q. Price is equal to 2Q. And QS is equal to 1/2 PS. Okay. And then we, again, just plug this into our market supply curve. We have 40 times 1/2 PS, which gives us 20 PS. Okay, so that's our market supply curve, and it's going to look a little different. It's going to be linear. Supply curve. Okay. And then last but not least, we wanted to solve, so we'll do that here, and it's going to give us a much nicer number. So we have QS equal QD. QS is that's just equal to 20 PS. And our QD is equal to 10 minus PB. Because we have no taxes, PS and PB are equal, so we'll just call them both P. And we can solve. So this is 21P is equal to 10, which gives us P star is equal to 10 over 21. Nice. So this is our equilibrium price. 10 over 21. So then to find the market quantity, all we do is plug this back into either the supply curve or the demand curve, and almost always the supply curve is easier. So always pick the easier one. So QS is equal to 20 times P, which is 10 over 21. So this comes out to be 200 over 21, and that's our quantity. $200 over 21. Let's make this a nice punchy red. All right. Great. So let's just make sure we've answered everything for the question. Find the short run equilibrium. Nice. Done that. So next we calculate consumer surplus and producer surplus. So part C. So we want to calculate two areas. And it turns out in this problem, neither of them requires an integral. But we're going to do it with an integral to show generally how it's done. So firstly, we want to integrate under the supply curve. excuse me, under the price, let's just write this out. Producer surplus is equal to the integral from 0 to Q. In this case, it's going to be Q star, whichever quantity we're exchanging at. And we integrate between the price minus the marginal cost, dx. So just to be as clear as possible, marginal cost is a function of something. Typically, this is Q, but because we're integrating one of the ends of our integral returns a Q, we're going to use x as our free variable, dx. Okay, so this is the definition of producer surplus. So in this case, because this is defined for the firm, and because we haven't really defined marginal cost for the market yet, we have to be a little careful here. This is for the individual firm. For the market, we want to multiply this by 40. So what we can do is realize that the marginal cost curve gives us the individual supply curve. And actually, let me rewrite this. So because the supply curve is coming from the marginal cost curves of the firm, I got a little ahead of myself writing the 40 out front. We have to worry about the P here. But because the marginal cost is, the marginal cost gives us the supply curve, when we're looking at the producer surplus for the market, because we don't have to worry about the shutdown condition for the firms individually, we can, so this is the definition for the individual firm, but we can write it for the market. So this is for the firm, and this is for the market. So we're gonna maybe put an asterisk here. We're gonna rewrite this as the integral over the price minus supply curve. Okay. So the reason we're doing this is intuitively, right? We're trying to find this area represented in blue. We know the supply curve. We don't have to deal with the shutdown condition, and because of that, we don't have to worry about fixed costs in the short run affecting our shutdown condition. So we're just going to integrate over the supply curve. Okay. You can equivalently think of this as, for the firm, we calculate the producer surplus and then we multiply by 40. And that's sort of what's going on in the background here. So either way you do it is perfectly fine. And I haven't checked it here, but they should be mathematically equivalent, so that the number you get should be the same either way you do it. And we could check that, but I think we'll skip it for the sake of time. Okay, so produce a surplus is that blue area, which is this integral here. But you could do it a different way. Okay, so the integral is p times x. Sorry. If you can hear chatter in the background, I certainly can. So we want the derivative of the thing I'm writing. Sorry. This p is a constant. We're differentiating with respect to x. So we have p times x minus, and our supply curve, so we have ps. Maybe a better way of writing this is ps as a function of x. So ps as a function of x is equal to, I can rewrite this. We have ps as a function of qs, which is qs over 20. So ps as a function of x is x over 20. So we have 120 out front. Then we have 1/2 x squared. And this is from 0 to q star. And we can just verify this is the correct integral, because when we take the derivative of this whole thing, we get back what we put in. Okay. Maybe it's entertaining, maybe it's distracting. Okay. So, when we plug in 0, everything goes to 0. So, we're left with plugging in q. So this gives us p times q star minus 1 over 20. Well, let's just multiply 1 over 40 times x, plug in for q star, and then we subtract off 0, but that's just 0. So let's evaluate this. So this, maybe we'll write p star here, just so we're clear which p. Okay, so we can plug in our prices. We get 10 over 21. We plug in our quantities. We have 200 over 21 minus 1 over 40 times 200 over 21. Okay, and evaluate this. So we can multiply. I'm just going to actually leave this as is for now. And let's do this for the firm and just verify that these are equivalent. So for PS, we'll use star just to denote the firm. We have 0. And just as sort of intuition for the graphical intuition for what we're doing, we have our our price, which is the same equilibrium price, and we have our linear marginal cost curve. So all we're doing is finding this, which is the PS for the firm, and we're multiplying it by 40. Okay. So the PS for the firm is PS for the firm is the integral from 0 to their individual quantity, which is Q divided by 40. So Q is equal to Q star divided by 40. And our Q star is 200 over 21, and then we divide that by 1 over 40. And actually, let's just leave this as is. So we have 200 over 21 times 1 over 40. And we integrate from P to our marginal cost, which we have defined up above as 2Q. So P, MC is equal to 2Q. So this is 2x. We're using x as the free variable, dx. Okay. So this gives us px minus 2 times 1/2 times x squared. And then we evaluate this at 0 and 200 over 21 times 1 over 40. And we can just verify when we take the derivative of this thing, it gives us this thing. And that's the check that our integral worked. Okay, so we're going to ignore this 0 because everything goes to 0 when we plug in for 0. And here we get price, which is 10 over 21 times 200 over 21 times 1 over 40 minus, and this 2 cancels with the 1/2, so all we're left with is 200 minus 21 times 1 over 40 squared. Okay, and I think I forgot a squared term up here as well. This was squared, so this is squared. Okay. So let's just compare this. So let's so we say PS is equal to 40 times PS squared. This starred. So this is the producer surplus for the firm. We multiply by 40. We should get the producer surplus for the market. I'm doing this live, so it may be, I may have to check my math. Okay, so the producer surplus for the market is 10 over 21 times 200 over 21 minus 1 over 40 times 200 over 21 squared. And then next, we have 40 times both parts. So first we have 10 over 21 times 1 over 40 minus 40 200 over 21 times 1 over 40 squared. Okay, so let's just do some cancellation here. This cancels with, maybe we'll square both of these. The 40 cancels with the squared, so all we're left with is 10 over 21 times, and what did I forget? Oh yes, we had sorry, this is getting messy. So this is 200 over 21 minus, then we have our 1 over 40 times 200 over 21 squared. Okay, so that works. So that's one check of the math here. So that's our producer surplus. It was somewhat involved. So let's turn now to consumer surplus. So consumer surplus is just the integral from 0 to Q star from the price for the buyer as a function of X, which is our demand curve, to, in this case, we're going to our equilibrium price. And then we just integrate over the free variable X. So PB as a function of X is equal to 10 minus X. Okay. This is just rewriting our demand equation. PB is a function of QD is equal to 10 minus QD. We're just replacing for X. Okay. So this gives us 0 to Q star, 10 minus X minus P star dx. So evaluating this integral, we get 10 times X minus 1/2 X squared minus P star times X, evaluated from Q star to 0. Okay, so our Q star is 200 over 21, and our P star is equal to 10 over 21. So we can evaluate we have, and again, our 0 is going to cancel everything out in the integral. So this just gives us 200 over 21. Multiply that by 10, we get 2,000 minus 1/2 times 200 over 21 squared minus 10 over 21 times 200 over 21. And that's our consumer surplus. Okay. For the sake of time, I'm going to leave this unsimplified. All right, so that's part C. Part D is to find the new equilibrium after a tau tax. So I haven't defined what the tax is, which gives us some flexibility. Part D. All right, so the first setup, right, is to write down the relationship between prices. So we have a tax imposed on the market where the price of the buyer is greater than the price of the seller by the tax. All we have to do to solve for this new equilibrium is take price of the buyer, which is equal to 10 minus Q. And technically there's a D here, but because we're setting QD equal to QS in equilibrium, I'm just going to drop the subscript. Our producer price for the seller is equal to is it 1 over 20 QS over 20. So that's 1 over 20 times Q. Okay. So to solve for the equilibrium, all we do is plug PB into PB and PS into PS. And that gives us 10 minus Q is equal to 1 over 20 Q plus tau. And then combining like terms gives us 10 minus tau is equal to Q plus 1 over 20 Q, which is 21 over 20 Q. Okay, so that's there's a 21 shown up here, which is nice. And then we'll just rearrange this. So we have Q star is equal to 20 over 21 times 10 minus tau. Okay, very nice. So then P star, we just take our Q star and plug it in to either the supply curve or the demand curve. So in this case, I mean, almost always, it's easier to start with the supply curve. So we'll call this PS star. So we have 1 over 20 times 20, 21, 10 minus tau. And these 20s cancel, which just leaves us with 10 minus tau over 21. So here we can just take our relationship between prices and find that PB star is equal to 10 minus tau over 21 plus tau. And we can simplify this to, we have 10 minus tau plus 21 tau over 21. And that gives us 10 minus 20 tau over 21. Okay. Oops, this is a plus. All right. And this gives us a pretty nice way of evaluating the incidence of tax, because you'll remember P star was 10 over 21. So we can just sort of see here that the seller's price is going down by some, but not much, and the buyer's price is going up by a lot. So for the incidence of tax, right, is going to fall mostly on the buyer. Okay. And if you wanted to check that your math is all right, I'm going to skip it here. You can take the price and plug it back into the demand curve to just verify that the quantities are the same, but I'm going to skip it here. Okay, so part, so that was D, I guess this is E. So we want to find the change in consumer surplus and producer surplus. Part E. So let's just graph this first. And then I have to go. Okay, so we have our downward sloping demand curve. We have price on the vertical, quantity on the horizontal. Oh, we already drew that. 10 and 10. Then we have our supply curve. And now we've wedged the supply and the demand curves. So we have the price for the buyer is equal to 21 plus, 10 plus 20 tau over 21, and we have 10 minus tau over 21. And here we have 20 over 21 times 10 minus tau. 20 over 21 times 10 minus tau is our quantity. So our consumer surplus is this area here, and our producer surplus is this area here. Our government revenue, which we don't need to calculate, is this area, and then our deadweight loss is this. Okay. So producer surplus is integral 0 to 20 over 21 times 10 minus tau from P S to the supply curve, which is 1 over 40, is it? One over 20. 1 over 20 times x dx. Okay? And this video is getting long. I'm going to leave this unsolved, maybe as extra practice if you'd like. But that's the integral for producer surplus. The full solution to the problem is to take this value and then subtract off what we found from before. PS from before. Call this PS prime. Okay? So then consumer surplus prime is equal to the integral from 0 to 20 over 21, 10 minus tau. And here we go from the demand curve, which is 10 minus x, to the price for the buyer. And this is dx again. And again, we're subtracting off the old consumer surplus to get the change. So maybe we call this delta CS and delta PS. Okay. So evaluate this integral to get the change, and then after we've subtracted off is how we get the change in consumer surplus and producer surplus. Okay, sorry to leave you here. I have to take off. I'm going to post this, and then like I said, if you are struggling and you want to submit this over the weekend, feel free to take the time you need to work on this. This will not be on the mini exam. The mini exam is just on general equilibrium. All right.